Let's graph the intersection, that's the word and, of the two inequalities. The first one is negative 4x minus 1 is less than 3. The second one is negative x minus 2 is greater than 3. Now, since these are complicated inequalities, step one is to simplify each of the inequalities. So taking the first inequality, let's see what we get. We've got negative 4x minus 1 is less than 3. So the first thing we do is move the negative 1 to the other side, okay, by adding 1 to both sides. And that leaves us negative 4x minus is less than 4. And now we divide both sides by the coefficient negative 4. But you know that when you multiply or divide an inequality by a negative number, you must switch the direction of the inequality. You should have an alarm going off in your head. We just divided both sides by a negative number, so we have to flip the less than into a greater than. Okay, continue. Cancel the negative 4s. We get x is greater than negative 1. Okay, intersect that with negative x minus 2 is greater than 3. Move the negative 2 over by adding 2 to both sides. We got negative x is greater than 4. Get rid of the negative 1 coefficient by dividing both sides by a negative 1. I said divide both sides by a negative, which means the alarm should have gone off in your head, and you'll flip the inequality sign to the less than direction. So we have x is less than negative 5. We're intersecting these two simplified inequalities. So step 2, stack the number lines. Okay, first we stack the number line for x is greater than negative 1, and then x is less than negative 5, and then the union of these two, the intersection of these two. Upside down cup is intersection. All right, the first number we'll stack is a smaller number, negative 5, and then the larger number to the right is negative 1. That's the larger one. Now shade everything that's greater than negative 1, but do not include negative 1. Put a round bracket on it because there's no equal portion. Now in the second set, we're going to shade everything smaller to the left of negative 5, but do not include negative 5. Put a round bracket. And now take the intersection. And remember what it means to take the intersection. We're going to look at each region, and we're going to ask ourselves, is there shading in that region in both of these sets that are being intersected? If the answer is yes, then there will be shading in the intersection. Remember, you think about it as an intersection of two streets. When you're standing in the middle of the intersection, you're standing simultaneously on property that belongs to Street A and Street B. That's the only way you could get that property in the intersection, is to have it simultaneously belonging to both of the streets. That's the idea here. Okay, for values of x to the left of negative 5, we do not have shading in the first inequality, but we do have shading in the second inequality, but that's not enough to get it into the intersection. And for values between negative 1, 5 and negative 1, there's no shading anywhere above in either of the sets, but for values of x to the right of negative 1, yes, we do have shading in the first, but not in the second. Now remember, what does it take to belong to the intersection? It takes simultaneity, and we do not have that for any values of x. There are no values smaller than negative 5, between negative 5 and negative 1, or greater than negative 5. There are no values on that real number line that live simultaneously in both of the sets. And that is clear by looking at the graph. So what does that tell us? It tells us that this is an empty number line, and the solution is empty set. There are no solutions. There are no elements in common in these two sets. So there's the answer, which is the first set, intersect the second set, is empty. Empty.